Hello everyone, this video will demonstrate SpecChecker-Int, an extensible concurrency bugs detection tool for interrupt-driven embedded software. Interrupt-driven programs are widely used in safety-critical areas, including aerospace, automotive electronics, medical equipment, and so on. Concurrency bugs in interrupt-driven embedded software are both prevalent and diverse and can lead to severe safety consequences, such as atomicity violations, out-of-bounds array access, divide by zero errors, and more. Therefore, detecting concurrency bugs is crucial for exposing potential critical safety concerns in interrupt-driven programs. There are some tools related to concurrency bug detection. However, their detection is limited to specific methods, which results in high costs for comprehensive testing. We propose SpecChecker-Int to provide an extensible framework for detecting concurrency bugs in interrupt-driven embedded software. We recently expanded it to include 3 concurrent bug checkers, IntAC, IntBuf, and IntBZ. To add a bug type for testing, a developer only needs to define the requisite components within the checker and register them with the checker registrar, thereby integrating the new rule into the tool framework. The bug detection process is then automatically handled by the engine. Our tool takes the source code and task, interrupt configuration as input and uses pre-analysis to generate the essential foundational data support for subsequent analyses. The engine then invokes the bug critical sequence collector from the checker to identify critical interleaving sequences. Next, it selects representative preemption points to refine these sequences, reducing redundant paths. Finally, an SNT solver uses the path conditions and bug trigger condition definition provided by the checker to systematically detect concurrency bugs. This video shows how to obtain our tool, and it also shows how you can apply the tool to an example with concurrency bug. This is the official website for the project that contains the executables of the tool and detailed instructions on its usage. I'm just following the instructions given on this website so that you will know where to look on this website to get access to objects as quickly as possible. I'll be using a Windows machine for this purpose. The first step is to make sure that you have the appropriate tools installed on your computer. You will need to clone the repository on your local machine. For that, you can use the following command provided that you have Git installed on your system. You will be able to download the project without any problem. Now, the tool is ready to use. I'm using the example that is shipped with this repository. Before running the analysis tool, let's analyze this case, which involves out-of-bounds array access. In this example, the function shramcheck zeros the elements of the buffer receive _buffer _b, while int_OISR updates the value of the counter send _frame _num _b under specific conditions. We can see that in the shramcheck function, the developer has added code between lines 22 and 26 to ensure that the index in line 28 remains within the array bounds. These safeguards are only effective under serial execution. If the program reaches line 22 and the value of send _frame _num _b is buffer _size1, and the interrupt routine preempts execution between lines 22 and 23, satisfying the conditions at lines 37 and 38, the interrupt routine modifies send _frame _num _b to buffer size. When int_OISR are finished, this modified value is assigned to index, causing an array out-of-bounds error at line 28. Then I will use SpecChecker-Int to analyze the C file. This is done by simply using the following command. These command line parameters include the analyzed file, concurrency flow entry and corresponding priority and output folder. Let's see what the output is after the run is over. Let's take a look at the output of the tool through the JSON file. This file for each bug includes detailed information, including the type, the code location line and column, the source file path, the shared variable, and the interrupt point information. We can see from the results that the tool detected an array out-of-bounds access at line 28, caused by a preemption of the interrupt routine at line 23. Thank you for watching.